Welcome to EPG Pathshala in Computer Science. This is a series of lectures in computer networks. So, we have been looking at protocols that are used in networks to support multimedia applications. So, in continuing with that, we will be looking at two other sets of protocols today. So, we will look at something called RTSP and the H.323 stack of protocol. So, RTSP is the first thing that we will take a look at, which is a real-time streaming protocol, and then the H.323 protocols. So, if you look at the real-time streaming protocol RTSP, it's actually an application control protocol for controlling multimedia streams. So, it is not an application data transmission protocol, it is more of a remote control protocol between the client and a server. So, we all know that when you are receiving data from a server, or let us say especially when looking at a video or an audio, you would like to do these operations such as pausing the audio or video, replaying or moving forward and so on. So, in order to support this kind of remote control typically kind of operations, we have this protocol called the RTSP protocol. So, the way it works is that you have your client which will be using the RTP protocol for transferring the data, and RTSP will be used for controlling the session, okay, information related to the session in terms of these kind of controls. So, okay, so the audio video decoder RTP and RTSP would be running on the client side. Similarly, on the server side you will have an audio video decoder RTP and RTSP running. So, RTSP talks to RTSP, RTP talks to RTP. Okay, this is the overall architecture in which the RTSP is expected to work. Okay. So, what are the various operations that are supported by RTSP? If you look at that, it allows you to retrieve media from a server. It can invite a media server to a conference and can also record a conference. So, let us say a conference is going on, that conference information can be recorded at the server. So, you have just as in a audio player or whatever, you will have options to record, play and so on. Similarly, all those options are basically available here in the RTSP protocol as well. Okay. And if you look at the protocol design, again you will see that as most application layer protocols are done, this is also a text based protocol, okay, and it is transport protocol independent, and it supports any session description. The session description could be done using protocols such as SDP or using XML or any such description kind of a protocol. Again, it is very similar in design with HTTP, but of course there are certain differences. Okay, so the client server and server client requests are handled here, and the server maintains a session state. Okay, that is an important difference when compared to HTTP. HTTP, remember, is a stateless mechanism, and the data is carried out of band. So, the control information is carried separately, data is carried separately. So, those are some of the differences that we have with respect to HTTP protocol. And it works either with unicast or multicast. Okay. So, let us look at some of the details of the RTSP protocol now. So, the way it is expected to work is in the following manner. So, you will have on your client machine, you have a web browser and you have a media player. So, the web browser will be used to request information about the media file that you want to download. So, you can get some kind of information about it, which means you are getting some meta information. So, meta file is obtained from a web server using the HTTP protocol. Once that is obtained, then the web browser passes that information, that meta file, to the media player, and the media player now can use RTSP protocol, okay, to send certain commands, streaming commands, okay, along with the meta file to the RTSP, to the media server, and the media server now can respond back in terms of using the RTSP messages, and the content will be transferred between these two using the RTP protocol. Okay, this is, so you can see that RTSP is expected to work along with HTTP on one side and RTP on the side. So, it is kind of providing a particular unique function which is in between these two, okay, which is not done by HTTP, which is not done by RTP. So, RTSP provides that unique functionality. So, that is the speciality of the RTSP protocol. So, the same thing if you look at the order in which the messages will be sent. So, you can see that the client will typically send one HTTP GET message to the web server, and that will respond with the session description. Now, the client can send a setup message to the media server. Now, the setup you can see will be a RTSP kind of a message. So, you will get a setup message, it will get a response from the server, send a play message, gets a response from the server. Once the response is received, these are done using RTSP, then playing of the message of the media can start, which will be done on top of RTP. So, RTP audio, RTP video and so on, okay, and RTCP will be used to send the control information. So, this will be done separately, and once in between, if you want to pause, you can send a pause command through RTSP, get a response to that, Okay, and similarly at the end you can send a close command and close the session. Okay, this is the these are how the messages are used to do this interplay between the media server and the client. Okay, so if you look at the major methods that are supported in RTSP, you have what's called as a setup message. So this is basically used to allocate resources at the server. So the server on receiving this setup message will allocate resources for a stream and start an RTSP session. A play is used to start the data transfer on a stream, pause is used to temporarily halt the data transfer, and a tear down is to free the resources of the stream, no RTSP session on the server anymore. In addition to these major methods, we also have some additional methods. So additional methods, there are quite a few of them. So we have something called an options message. The options method is used to get available methods. Okay, you can get what are the available methods that are supported by that server. So that's information you get. There is something called an announce method, which is used to change the description of the media object. So we said that in between you can change the description of the media object. So that is done using an announce method. Then you have a describe method, which is used to get some low level description of the media object. A record method, which is used for the server to tell the server to start recording the data stream. And then there is a redirect, which is used to redirect the client to a new server. And there is something called set parameter, which is used for device control or encoding control. Some parameters can be set. Okay, so these are the different RTSP methods that we have. Okay. So the way the entire thing could work would be like this. So the client, as the first step, would get a description from the media description web server in the form of an SDP in using SDP format, for instance. So gets that information. Step 2, it opens streams with the using RTSP to let's say to the audio server, right? And then step 3, it can start playing. Okay, and step 4 will be tear down. Same thing can be done with an audio server, same thing can be done with a video server. Okay, so this is basically how the client would be able to contact a audio server and a video server using RTSP and start playing the content. Okay, so this is again the same example given in the form of a time sequence. So HTTP get is sent, the presentation description in the form of SDP is obtained, then a setup message, okay, and then for which a response, then you send a response for that, and then the RTP audio video is sent, okay, and then you finally tear down the message, tear down the connections. This is these are the steps that we have in RTSP. Okay. Now we said that we will be looking at another set of protocols called H.323. Now we need to understand where this new set of protocols are coming from. Okay. So they are actually not a new set of protocols as such. In fact, they are an older set. Okay, in fact, much before or almost contemporary with the SIP protocol. Actually, I think it's kind of earlier to the SIP protocol. So these are protocols, right? It's a set of protocols which has been proposed by the ITU group, that is the telecommunications group. So we have different standards bodies, right? One which is responsible for telecommunication, telephone kind of communication, and another one is responsible for the internet kind of communication. So the H.323 is a standard proposed from the telecommunication community, the telephone community, in order to support multimedia data transfers over the network. Now remember that everybody started moving towards voice, over IP, over moving things over IP. So even telephone networks want to transfer data over IP. So you want voice over IP. So in order to support voice over IP, ITU has come up with a set of protocols that need to be used. Okay, that goes under the name of H.323 protocol stack. Okay. So, so this is essentially meant to support multimedia communication over packet networks. Okay, that's what this H.323 protocol is used. And it along with it, there are other protocols like you have for instance H.225 for call control. So along with these protocols, the H.323 will work. And it's a very extensive protocol, which is why we may not be able to look at all the details of that. We'll just get an overview of the H.323 protocol. It's a very detailed protocol with the complete recommendations running to several hundreds of pages, and the protocol is known for its complexity, which is why when we talk about the SIP protocol, we always say it's a very simple protocol. That simplicity of the SIP protocol essentially comes when it is compared with the H.323 protocol, which is also used for the same purpose of controlling sessions, establishing calls and so on. So which is why we kind of have moved more or less to SIP protocol. But our discussion on multimedia support in networks will not be complete if you have not looked at H.323. So, which is why we should definitely take a look at this H.323 protocol. Okay. So, as we said, it is published by ITUT, and it was developed from the H.320 standard, which was originally meant for conferencing over ISDN networks, the digital networks which are used for telephony, okay, and it was adapted from unreliable packet based networks. So, it is widely used for conferencing and IP telephony, and there are multiple releases of this protocol starting from 1996. So, you have various things that are supported. You have voice support, you have scalability and web support, all these are now supported. Okay. So, if you look at the devices that are used in a H.323 network, so we talk about devices called H.323 terminals. Now, these are the ones which are initiating a call or which are at the end of the call. So, then there is something called a H.323 gatekeeper which has certain functions, and then you have a H.323 gateway. This gateway is the one which will connect to other networks. So, it may connect for instance to a conventional telephone network, your public switch telephone network PSTN, to which another a telephone may be connected. So, you should be able to make a call from a H.323 terminal which is on this network through the IP, and through a gateway it should be able to connect to a conventional telephone network and establish a call. Okay. So, to that end, for doing that that functionality, we have these different components, and there are a number of protocols that are used for these components to talk to each other. So, we will take a look at that. Okay. So, this again gives you a picture of how H.323 will be used in a voice over IP environment. So, you have a H.323 terminal which will talk to a H.323 gatekeeper. Now, this gatekeeper is the one that is responsible for call admission and so on, and so through this H.323 gatekeeper, the terminal will be able to talk to the will be able to send voice over IP calls on the IP network, and it will go to a gateway. This is our H.323 gateway that we talked about. This may be connected to a PSTN network, to which is a circuit switch network, should be connected to a telephone network. So, you can see that H.323 will allow a packet switch network to be able to talk to a circuit switch network, or a caller on a packet switch network to be able to talk to a callee on a circuit switch network. So, this kind of thing is facilitated by means of these modules called gatekeeper, gateway and so on. Okay. Now, if you look at the H.323 protocol stack, you can see that there are lots of protocol numbers that are specified here, which is why we say normally that it is a very complex set of protocols that is specified over here. But if you look at each of them, it is not all that complex. You can understand the purpose of each of these things. Okay. So, you can see that there is something called RAS, right. So, RAS stands for registration, admission and status. Okay. So, this is used for the end terminals to register with the gatekeeper. So, the control is handled by the gatekeeper. So, the terminals have to talk to the gatekeeper to establish their to register themselves, to get admitted and so on. So, that is done by means of this RAS protocol. We have a H.225.0 protocol which is used for this purpose. Okay. And then there's then we have a control here. There are two protocols here, Q.931 and H.245. Now, this H.245 is used for capability negotiation and channel setup. That is, what is the capability of the two devices, they need to negotiate that and set up the channel. That is done by the H.245 protocol. Q.931 is used for call setup and call teardown between two terminals. Okay. So, this is a call setup, that is a channel setup. Okay. So, Q.931 is used specifically for setting up the call and tearing down the call. So, you can see this forms part of the control. Then you have a T.120 protocol, which is the data protocol for multimedia conferencing. Okay. So, application sharing, whiteboarding and other things are supported by means of this protocol here. Okay. So, you can see that all these three, the two control protocols and the data protocols run over TCP, because you need the reliability for that. And for audio and video data to be transmitted, you have different codecs that are supported. You have the H.263 codec for video, and then you have G.711, G.723, 729 standards which are supported for audio. These run over RTP, which runs over UDP, okay, and they are transported through that. Then for the audio video control, you have the RTCP protocol. So, you can see that this full set of protocols all put together give us whatever is required for a multimedia data transfer, right. You have your call admission, call setup and so on. Then you have your channel negotiation, channel capacity setup and so on. and then you have control in terms of whether you are able to get connected to the network and so on. And then the audio video codecs which are required for doing it, then the controls that are required. So everything you can see is kind of handled by this H.323 protocol stack. Okay. And RTP and RTCP, we already know the purpose of these two. Okay, they are used for real-time traffic synchronization and transportation. Okay, okay. So let's look at a little bit on each of these things. Okay, the overall setup procedure. Now, how is it that all these different protocols will actually be used in making a call? Okay, so let's look at the interplay of these different things. So first thing that will be done will be registration and admission. So for this purpose, it will use the RAS protocol. Okay. Then a call setup will be done, where your Q.931 protocol will come into play. Once a call is set up, there will be a terminal capability negotiation, channel setup and master slave detection, right? Who is going to be the master and who is going to be the slave and so on. That is done with the help of the H.245 protocol. Okay. Once all these are done, now a stable connection is established, so the call can now proceed. Okay. So stable call is established, the call proceeds. When that is happening, data will be transmitted or transferred using RTP and RTCP. Okay. So then once you are done with your call, you want to close the channel. So closing the channel again is done with the help of H.245. Then you call tear down, which again your Q.931 will come into play to tear down the entire connection. And then a disengagement message with the gatekeeper, that is done with the help of the RAS protocol. So you can see that all these protocols have certain distinct purposes or roles that they have to play. So that's how all these things will kind of work together. So as we said, H.323, it's a collection of standards. H.225 is used for signaling, RAS call signaling and so on. And H.245 is used for multimedia control protocol. So there are also other related standards. We have something called H.235, which is used for security within the H.245 based systems. And then H.245 interworking with the PSTN systems, and there is something called H.450, which is used for supplementary services. So there are you can see that it's getting more and more complex because there are so many different standards that are available. Okay. So we said that we talked about these different components, right? Gatekeeper and so on. So let's look at what exactly happens in each of these cases. So the H.225 RAS, right? So that is used to talk to the gatekeeper. For what purposes? There are two purposes. One is for registration and one is for call routing. Okay, those are the two things for which it's used. So the H.225 call signaling is used for call establishment, and H.245 is used to control the established multimedia session. Okay, this is what we have. And as we said, RTP and RTCP will be normally used to carry the media. Okay, that's what we have. Okay. Now coming to the RAS, the registration, admission and status. So this is used, as I said, between the endpoint and the gatekeeper. Now what all does it allow you to do? It allows the gatekeeper to manage the endpoint. It allows the endpoint to request admission for a call, and it allows the endpoint to resolve addresses. Okay, so there may be some address resolution that may be required, that is handled by this. And RAS messages that are used, okay, you have messages for gatekeeper discovery and registration. So gatekeeper discovery messages go as GXX, okay, something will be there. Similarly, registration messages are RXX kind of messages. So gatekeeper discovery, because there may be more than one gatekeeper, you need to discover the gatekeeper, right? That will be done. Then you register with that gatekeeper. So you have a registration message. Then there are admission messages, location messages and bandwidth messages. So you're specifying information about whether you want to get admitted, whether your call has to be set, channel has to be set up admitted, what kind of location information has to be specified, bandwidth details and so on. Similarly, there is a disengage, DXX, to disengage from the RAS, from the gatekeeper, okay, and other information, additional information can be specified. So this will be the RAS messages that we have. Okay. So if you look at the 225 call signaling that is there, it is used to establish the calls between the two entities, to the endpoints. Okay. So it's actually derived from the Q.931 message protocol. So example messages that you will have here are very similar to what you would normally have in Q.931. You will have something called a setup, call proceeding, ringing, alerting, right? So those are the kind of messages we normally talk about when we talk of call establishment. So those are the kind of messages you will find in H.225. H.245 we said is used for terminal capability exchange. So here you will have provide information about various codecs that are supported, the channel signaling to open the media sessions, for doing conference control. Okay, these are all various things for which this will be used. Okay. And there are also some optimization options which are added in H.245. For instance, the H.245 can be tunneled in a H.225 call signaling channel. Okay, so which is normally it will be transmitted in its own TCP connection, but it can also be channeled or tunneled along with the H.225 call signaling channel. And there is also an option called a fast connect which is available, where you don't have to actually establish a H.245 channel. Instead, all the H.245 related information fields, they are passed as part of the H.225 setup message. So you can see why it's called fast connect. So instead of doing a H.225 protocol access then a H.245, you're kind of combining these two so that you get a faster connect, you're able to connect faster. So these are some options which are supported on H.245. So now let's look at a quick comparison between the SIP protocol and the H.323 protocol. So we said that both these are used for similar purposes, right, that is for establishing signaling and so on. So what are the key differences between these two? One is very obvious. We can see that SIP is a very simple protocol, whereas H.323 we see is a very complex protocol. So let's look at other differences that are there and what are the advantages, disadvantages of each and so on. Okay. So H.323, it's another signaling protocol for real-time interactive multimedia. Now SIP is a single component. H.323 is a set of protocols that we have. Okay. SIP works with RTP but does not mandate it, whereas H.323 has to necessarily work with RTP. Okay. So SIP can be combined with other protocols and services. So you can see that there is a lot of flexibility part that is coming into SIP. And the H.323 comes from, as we saw, from the telephony world, from ITU, whereas SIP comes from the networking world, from IETF. So it borrows much of its concepts from HTTP. So it has more of a web flavor, okay, whereas H.323 you can see will have more of a telephony flavor. And H.323 is complete in the sense that it has a suite of protocols for multimedia conferencing, signaling, registration, admission control, transport, codecs, everything is specified as part of the H.323 standard. Whereas SIP has a very simple approach. It uses the KISS principle, which is keep it simple and stupid. So it does not specify all these things. So it can basically interwork with other protocols, right. So that is the idea that is used in SIP. Okay. So if you look at the similarities that we have between SIP and H.323, similarities are that both can use RTP and RTCP for media transport. Of course, H.323 mandates it, SIP does not mandate it. Okay. And both will support call routing through proxies and gatekeepers, okay, using username, phone numbers or URLs. Okay. This flexibility of not having to always know only the phone number, but you can just also use usernames and URLs to locate the end user. Okay. So this kind of facility is supported with the help of proxies in the case of SIP and with the help of the gatekeepers in the case of H.323. So you can see that in a sense the gatekeepers are doing the job of what a proxy would have done in case of SIP. Okay. And the flows are similar. Okay. Now the differences are that in the encoding that is used, SIP uses a simple text based encoding, whereas H.323 uses a ASN.1, which is an abstract syntax notation that is used. As a different standard is used for the encoding all the messages and so on. And there is also a difference in the standardized feature sets that are supported. For instance, you have conference control, caller preferences and other things which are supported in H.323. Okay, some of the advantages of H.323, because when you look at these similarities and differences, it almost looks like we are saying that, that SIP always seems to have more of advantage. Okay. So what are the advantages of H.323? Actually, you will see that H.323, it has more compact messages, and in certain senses it is more mature because it takes the experience of the technology that is kind of very well established in the telephony world and brings those into the for the IP world as well. Okay. For the SIP advantages, on the other hand, if you see, it's very easy to prototype, very easy to implement because just a text based kind of a protocol. It's much more flexible, so provides for extensibility and more scalable. Okay, and the same messages are kind of used throughout the network. Okay, and there's a cleaner separation of layers. So SIP in that sense is a lot more in tune with the network that we are familiar with the TCP/IP model of network that we are actually familiar with. Okay, so this you can see are the major differences that we have between these two. Okay. And if you look at a little detail of exactly what kind of differences are there in terms of the messages used and so on. So if you take for instance the endpoint registration. So endpoint registration, SIP will do its endpoint registration using discovery and both discovery and registration by contacting the registrar. Okay. So the registrar is the one which keeps track of all information for SIP. So you have to, a SIP client has to therefore send a register message to the registrar. Registrar will respond with a 200 OK on success, okay, and a 300 on error. So that's the part that is used for registration, discovery and registration. Whereas in H.323, discovery is separate, registration is separate. So discovery is done by sending a message to the gatekeeper, which is called as a gatekeeper request message, GRQ message, and if it is confirmed, it sends back a GCF, gatekeeper confirmation message, and a reject message if it's an error. So GRJ on an error. Okay, and this is for discovery. For registration, we have a separate set of messages. So you have a registration request message sent to the gatekeeper, and which returns either registration confirmation or registration reject. Okay, so these are the request is rejected, so that information is sent. Okay, so you can see that there are two different sets of messages that need to be sent for in H.323 for discovery and registration, whereas in SIP it's just one single register message that needs to be sent. And SIP can also work with DHCP for you can use DHCP for discovery. So we said that it can use other protocols quite well, can kind of interwork with other things or coexist with other protocols very well. Okay. Second thing is you can look at the call setup. So if you look at the call setup, the SIP protocol will do its admission control and routing using the invite messages. So you have capabilities to route the invite messages through proxies. So admission control routing is all done with the help of these proxies. Okay. In H.323, you can do it using fast connect mechanism, which will do the admission control and routing using the ARQ messages to talk to the gatekeeper, which will return an ACF, a confirmation message on success. Okay. And if you look at call setup, the messages that you have exchanged would be like this. You will send an invite message, then you will have a 180 ringing which comes from the other side, a 200 OK indicating that call is set up, and then an ACK. So you can see that these four messages will kind of sum up the entire call setup process for SIP. Whereas here on H.323, you have a setup to a remote terminal. You will get a message saying it's proceeding, that's the message that will be returned, and then a connect message will be returned saying that it is connected. Then finally you will have an ACK which is sent from here which is sent to the remote terminal, which will be sent to you on top of UDP. Okay, so this is, you can see that there is a difference in the kind of messages that are sent and so on. Okay. So to summarize what we have looked at in this today's topic, we've looked at RTSP protocol, which is the real-time streaming protocol, which is, you can say, which is a remote control kind of a protocol for playing your audio and video from servers. And then we looked at the H.323 protocol suite. Okay. So the H.323 protocol suite we saw has a number of protocols are used for various operations that are required for multimedia communication end to end, right. So everything, whatever is required we see is that we require, we saw was provided in the H.323 protocol suite. Okay. So then we also looked at a comparison of the SIP and H.323 protocol. We had already looked at a SIP protocol in a previous session. So this quick comparison between SIP and H.323 basically tells us that we are moving more towards the SIP protocol, right. So H.323 is more complex, SIP is more is much simpler. So we are more and more the entire VoIP community is moving towards using the SIP protocol. That's becoming a more established protocol these days. So with this set of protocols that we have, okay, we have kind of covered all the protocols that are required for supporting multimedia communication. So we looked at RTP, RTCP, then we looked at the control protocols, right, and then RTSP, okay, SIP, SAP, SDP. These are all the various protocols that we looked at. So these protocols are the ones which allow multimedia communication to take place. Okay. Thank you.